Hi, I'm Adam. This is my app that I've been working on for 3 months. So this is the main page that you land on. You've got a login component here. You've got a chat component here and a menu component here. So if we just have a look at the menu. So in here we got a few options. We've got dashboard, that's our stats. Login is just a bigger version of this login component. Just gives it its own page. Current games is any unfinished games that we've got, ones we started and haven't finished yet. New game, we've got pass and play, which is 2 players, 1 computer. Just alternates white, green, white, green. This part doesn't save to a database, or there's no online activity associated with this at all. And then join game and replay, that's out of the scope of this assignment. That's going to be for future. Join game is going to be integrated with a Discord bot, and replays is just going to replay old games, but that's not part of this assignment, so it doesn't matter. So this login component here, this checks the username and password against a web token stored in the database. So we'll try and log in with a user that doesn't exist. We'll see what happens. Okay, invalid credentials. So this means that this username and password combination was checked against the database, and either this user doesn't exist or this user with this password is incorrect. So we'll try and register and see what happens. If these passwords are different, then it does a check to make sure these are the same before it proceeds. Okay, Brad is now registered, so he should be able to log in. And he's logged in. So when somebody logged in, their token is saved in the in this local storage here, and then this token is what gets checked and verified with the JWT library, JSON web tokens, I think. It gets verified against that along with a secret key. So we'll close that, and now Brad can chat. So because Brad's a brand new user, he won't have any stats, everything will be 0. So we'll go over and we'll have a look at a couple of other people. So here's a few users that I've been using for testing, so they should have information. So this login component that was here, it checked to see, we've got a user logged in, and then so it switched itself over to a users online component. So this is yet another component now. These people online here in the database, their status is either online or offline, and then this component goes through and pulls everybody who's online and adds it to a list here. Sockets being used in the interaction here, I've dialed it right back so that on hearing a new user event, rather than getting the information from the socket itself, it just triggers the browser to go fetch from the database. So sockets in this way are being used more as a triggering event rather than passing information. So these 2 users can chat as well. Also, if you notice that the list here is everybody that is not the person. So you got Dave and Brad and Adam and Brad and Adam and Dave. So that's just a filtered list that eliminates their own name. Now, logout events also trigger a database event. So if Adam logs out, you'll see that Adam disappears off this list here and this list here. So if we come back in here, and they're back online. Also, navigating away from the page is also a logout event. So you see the user disappeared there. Because these are two established players, we can have a look at some stats in the dashboard. So you see the Adam player has played a total of 5 games with 3 wins, 2 losses, and there's currently 4 active games. And the Dave player, has 2 wins, 1 loss, with 3 finished games and 2 active games. So if we go over to current games, this is the active games that haven't yet been completed. So you see the Adam player has 2 games against Dave, and there they are. So these can be restarted at any time. Could be 3 years later, it doesn't matter. And there you go. Now when a player wins, it's moved away from okay, so the black player wins here, and if we just go back to current games, that game is now gone because it is finished and it's off the active games list, and it's gone. Another thing I've implemented as well is the use of chat in here as well. So if Dave wants to play Adam, they can click here, and then the admin, you have been invited to a game. Now over on Brad's screen, you won't see that, but he can still chat. So the Adam player, all he has to do is just click this link here, and he's taken to the game. So in this way, it's similar to how normal invites work, which is Adam invites Dave, and on both of their screens, you'll be invited to a game. But the Brad player doesn't see that because he's not part of that invite system. He can now invite Adam. Now Adam's got 2 invites, Dave has 1. So we'll just get rid of that. Okay, so a normal game, you've been invited to a game, they can play. The way this is working, communication-wise, is again the sockets have no informational value. I'm using them more as a triggering event for this game data here. What happens is player 1 makes a move, a socket is emitted to the server saying a move has been made, and it's, white ant 1 to x15 y7 or whatever it happens to be. The socket then saves that data into the database, and once that database returns okay, saved, the server then emits another event, which is just on these 2 rooms. The rest of the app won't see the event. So the other player will hear the event, say something's changed. It will then go and check the database and pull the last set of moves, and then they'll be synced up. I moved away from having the sockets actually contain information on where pieces were, because games were getting out of sync if a socket was missed. But in this way, everything's synced up all the time, and it doesn't matter when you leave. If you close the browser at any time, the game is always saved in the most recent state. So if we go back now, and we go to our unfinished games here, and that's the newest one here. So that was the game that they were playing. And there you go. So they've just left the app instance altogether and been able to come back and continue the game. We also have an in-game chat here. This is different to the lobby chat, as it's only between the two players. So if there was 50 instances of 50 different games happening at the same time between 100 different players, none of their chats would interfere with each other. So I'll just put a couple of messages in here, and now if we go over to here, you see that the messages haven't been transmitted to this particular lobby, and likewise these messages won't come into this lobby. So I'll take you over to the database now, and we can see what information we are storing there. So this is the games document collection, and these are the games we've played. So the moves that have been transmitted between players is not the whole board. It is just the pieces array, with only pieces that have moved. So this player attribute here, that is the person that made the move. And then this is the data. So you have the piece ID and the location on the board. So that's Black Queen 0, move to X14, Y6. White Spider 1, move to X16, Y6. So I found it was easier to only transmit the pieces that had moved, rather than 500 squares of a whole board. So this should just have the first move. The first move is the White Queen move to 15X 6Y. How I was getting all those stats was just based off this finished and winner, and then filtered by name, and that's it. We also have a users collection here, and this is our users. So these are all my test users here. So the Atom player, this token here is the same token that is kept in local storage, browser side. So whenever there needs to be some sort of you might call sensitive operation, getting stats or anything like that, this token is transmitted, compared against the database version of the token, and if they match, then everything is sent. This password here, the password for the Atom player is just Atom, but this is now encrypted using the bcrypt library. So if these passwords were stolen, they'd be useless, because they'd need this plus the token plus the secret key. And this is how the online, offline, this list here is maintained. So whenever somebody is either logs in or anything like that, their status in the database is changed to online. Whenever they trigger a logout event, such as leaving the browser, clicking the logout, things like that, their status will get changed to offline. Whenever that happens, a socket again is transmitted between the server and all browsers that just says please update your statuses, who's online, and it will update all that from the database. So if you miss a socket event when you first come into the browser and the browser checks the database, it doesn't matter if you miss a socket event because it's all in the database. So this is the code. I moved all my database services to this services utility file because I was getting sick of changing this across 50 different pages, basically. So this controls all the getting and setting of information in the database. This is all client side. So for example, get the current board state. So the browser will call get board service, give it the game ID, which is this here. It will give it that, and it will send that Axios request to this API endpoint. If we have a look at the API endpoints, so that was a get request on /API/board. That calls get board, which is here. So this game model, which looks like this is the schema model for the game object. You have game, this is required, this is a key. Your players, the move schema.types.mixed is the only way I could find to actually stick an array of whatever's into the database. And then you got a winner and finished. So this game model, it finds one with the game attribute the same as whatever was passed in, and then all it does is just return the last move. So if we have a look over in the database here, in the moves, it will return this one. That is the current state of the game. These are only kept for like accounting purposes, I guess you'd call now. So then that just returns that as a JSON object with a status 200. We'll have a look at this one. So the logout function, it finds the person with the name, finds the document with the name of whatever name is passed in, who is a type of iUser, which iUser has a name, the token, a status, and a password. Then changes their status to offline and saves that in the database, and then returns done. The disconnect events that I was talking about is just handled by this socket on disconnect. So whenever the socket IO sees that the WebSocket port is closed, it finds the person who disconnected, and then it just changes their status to offline and saves. And then it tells every browser, somebody logged out, please check your online users. So we can have a look at the statistics a little bit. So this is the Dave player. If we have a look at the games, so we got Zach and Adam, and the winner is Dave. So let's have a look here. So Dave has 1 win, 1 loss, 2 active games, and 2 finished games. So if we change this here to Dave and update that, we should see these stats change. He now has 2 wins and 0 losses. If we change another one. Say, let's change this one here. And the winner was the Adam player. And change this here. Dave should have 1 loss and 2 wins. There you go, 1 loss, 2 wins, 3 finished games. I think that's about it. Thanks for watching if you made it this far. If you want to see a version of this running on the internet, it's at thehive.pw. Or if you want the code, it's at this address here. So github.com/hex/view-hive. So yeah, you can check it out if you want. Thanks.